And the last type of inheritance that we will see in shell coiling in snail. The scientific name is Limnaeperenca. Okay, this is the scientific name. So here, the shell coiling in snail, there is two types. One is the dextral, the coiling towards right hand side, means in the clockwise direction. This is in the clockwise direction. Dextral, the shell coiling. And here in this is clockwise because right hand side the coiling will take place, and this is the dominant state. If the coiling is in right hand side and it is clockwise, and it will show the dominant character, means big D or big D small d, because big D will suppress the small d. And this type of coiling will call dextral. And another type of coiling, it is the sinistral, the coiling towards the left hand side, and also it is anti-clockwise, means like this. In anti-clockwise direction this coiling will take place. So it is denoted by small d is recessive condition. Now what will happen if we cross a pure dextral female? So first you see pure dextral female, what type of gamete it will produce. In female there is a protein also present in the cytoplasm, you remember. In pure female it will give D, because both the gene have D. So one gamete that will come big D in the nucleus, and in the cytoplasm some proteins are present. Okay, this protein will show the dextral rotation. Okay, the protein is also means the for the dextral rotation, the coiling towards right hand side clockwise. Why? Because in cytoplasm one protein is present. So in pure dextral female, in cytoplasm this protein is present. But when small d means the recessive, this is the pure sinistral, when it will produce one gamete, small d will come in the nucleus, but in the cytoplasm there is no protein. Okay, because there is no protein is forming, that's why it is the sinistral, means anti-clockwise rotation is showing. Clear? Here protein is present, here protein is absent in cytoplasm. Big D is coming in the gamete, small d is coming in the gamete. Now what will happen if pure dextral male, suppose this is male, this is female, pure dextral male DD, this is P generation, cross with small d, that is pure sinistral for small d, and female, this is female and this is male. So the male will give D and the female will give this type of ovum, D in the nucleus and no protein in the cytoplasm. Without protein will show na sinistral. If protein is present, then it will show dextral rotation, so protein is absent. So when they fuse in F1 generation, it will produce big D, small d, and obviously in ovum nucleus there is no protein in the cytoplasm, so here also no protein, big D, small d. And this is the sinistral coiling. Why? You can ask me, ma'am. You can ask, ma'am, why? Because here is a big D is present. This is a dominant character, as I told you. So this is not only the reason. There must be a protein in the cytoplasm, right? There must be a protein in cytoplasm. So sinistral coiling, because for the dextral coiling in cytoplasm the protein must be present, but here there is no protein in the cytoplasm. So what will happen? So if we draw F1 generation this cross, big D, small d, male, female. In a Punnett square we have shown this thing, big D, small d, big D, small d, big D, small d, big D, small d. All the four offspring, there is no there is no, you know na, there is no protein in the cytoplasm. That's why all these, no protein in the cytoplasm, no protein in the cytoplasm, no protein in the cytoplasm, no protein in the cytoplasm. So all the 4 offspring will be sinistral, means they will move anti-clockwise, okay, because in their cytoplasm there is no protein. Clear? Now suppose this F1 generation now cross, selfing. Suppose this is one with male, one with female, because all their genotype is same. So DD female, DD male. As I told you, if they cross, now what will be the genotype? First we draw up unit square, big D, small d, big D, small d, male, female. So D, 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 small d, big D, small d, small d, small d. But what about this protein? The protein will come in the offspring or not? This female in future, because one big D is present, in future they will produce this protein in their cytoplasm in future. So this D has the protein. So that's why when this D fuse, this cytoplasmic protein will come in this offspring. Okay, so here also this big D is present. In future it will also produce protein because the dominant state D is present here. So when it fuse with this, here also in cytoplasm the protein will present, big T. Here also in cytoplasm the protein is present. Here it will be DD, but here to cytoplasmic, in cytoplasm the protein is present. That protein will also come here. In future in their cytoplasm the protein will present na. So when this D and this D, both they have cytoplasm in their both they have protein in their cytoplasm. So here in the cytoplasm the protein will present. So all the 4 have protein in their cytoplasm, and for that reason this all 4 will be the dextral. All 4 are dextral. Clear? Now you can tell me, ma'am, what will happen if a dextral female, small d, dextral means in their cytoplasm protein is present. In their cytoplasm protein is present, that's why it is dextral. And dextral female DD, here also in cytoplasm the protein is present. So what will be the offspring? Big D, small d. So big D, small d, big D, small d, big D, small d. But you see here, this is small d. In future it will not produce any cytoplasm in the, they will not produce any protein in the cytoplasm because there is no big D. Here big D was there. In future it will produce cytoplasm in protein in the cytoplasm, but there is no big D. So there is no big D, that's why in cytoplasm no protein. Now here in cytoplasm there will be protein because big D is present. So when it will fuse with this D, their cytoplasm in female, as I told you, from female cytoplasm will come in the offspring, not from the male. In beginning I explained that thing at the beginning. Only female will give the cytoplasmic material in the offspring, in the zygote, right? So in female cytoplasm there is no protein, right? So all the offspring will have no protein in the cytoplasm. In the male they have protein in the cytoplasm, but you know na, in the offspring the cytoplasmic material totally comes from the female gamete, not from the male gamete. So all the 4 offspring will have sinistral rotation, means anti-clockwise rotation. Clear? So this is again we are seeing cytoplasmic protein is responsible for the dextral and sinistral rotation, not the gene, the cytoplasm. If big D is present, big D is present, big D is present, big D is present, but the proteins are absent here in cytoplasm. That's why they are not showing the dextral rotating. Clear? So here also it is a very good example of cytoplasmic inheritance. Clear? So we have learned the three types of inheritance. First we have learned plastids. This is also responsible for cytoplasm because in cytoplasm plastid is present. Here we have seen that kappa particle that is also in cytoplasm that is present. That's why it is coming, the cytoplasmic exchange takes place, then the kappa particle is coming here. And here also we have seen in cytoplasm the protein is present, then it will show the dextral rotation. Clear? So these three are the most important example of cytoplasmic inheritance.